In number 1 here, we're told that this table lists input, output values for a function. So here's the inputs, here's the corresponding outputs. And what we want to do is complete parts A through C. Now, they're down here, but A says, is the change in the inputs the same? All right, so look for the change in the inputs. Now, what are we doing in the inputs? We're going from -3 to -2 to -1 to 0 to 1 to 2 to 3. So what we want to know, are these changing the same way? Look what we did here. We went up 1, up 1, up 1. In each case, we're going up 1. All right, so the answer to this is yes. So I'm going to say yes, the changes in the x's, the inputs are the same, and it's equal to 1 unit. Now B, all right, part B asks us, what about the changes in the outputs? All right, so look at the outputs. Now in the outputs, all right, here's the outputs. We're going from -10, well, let me get to right here. We're going from -10 to -7 to -4 to -1 to 2 to 5 to 8. So what are we doing here? From -10 up to -7, we're going up 3. From -7 to -4, we're going up 3. From -4 to 1, we're going up 3. And if you look at the rest of those, we're going up 3 in each case. So our answer to this one is yes. Those are the same, and we're going up 3. Now, part C is this function linear? All right, well, if the increases in the input are the same each time, and that gives us a constant change in the output, right? The outputs are increasing by 3 each time, then this function is linear. All right, so let's get it to right here. So yes, this function is linear. So it's sort of like this. Now our inputs here are going up 1. So the inputs are typically on a graph horizontal. So if you increase this by 1, then the outputs are going up, right? What are our outputs doing here? They're going up 3. All right, so this is be up 3. So if I increase it by 1 again, I would go up 3. Increase it by 1 again, I would go up 3, and that's going to give us a straight line. Problem number 2, similar to number 1, we're given a table that represents the function. Each one of these input values goes to exactly one output value. 11 goes only to 3.5, nothing else. Now, here's the question. Is the change in the input values the same? So what do you think? As you go from 11 to 27, well, here's what you're going to think, all right? 27 minus 11, that's 16. And then as you go from 27 to 43, all right, so what about 43 minus 27? Well, that's 16. And then as you go from, say, 43 to 59, all right, you have 59 minus 43. What's that difference? It's 16. So it turns out if you check all those, it's 16 all the way down. So the answer here is yes, and that changes 16 units. So the inputs increase by 16 units each time. Now, this is part A. Part B says, what about the output values? Are the output values increasing the same way? So as you go from 3.5 to 5.1, 5.1 to 7.5, 7.5 to 9.2, are those increases the same each time? So just check it out. 5.1 minus 3.5. All right, well, this gives me a 1.6. Now, let's take it up to the next one. What about this one here, right? So from 3.5 to 5.1, we increased by 1.6 units. Now, what about from 5.1 to 7.5? Well, you can see it's an increase, but by how much? So 7.5 minus, say, 5.1, well, that turns out to be 2.4. Now, these are not equal. So when we have equal increments in the inputs, we're not getting equal increments in the output. So this function, Okay, I'm going to say it this way. This function is not linear. Now, number 3, we want to get the slope of this line. So we've got a straight line here. I want to get the slope. Now, it looks like we might be able to do this. Now, I'm going to make this a little bit bigger here so I can see this. How about that? All right, if I try to do this by counting, now it looks like they've actually given us some points on the line. So I'm going to be down here at this point right here. Now, if I start at this point, what kind of changes, horizontal and vertical, do I need to make to get back to another point? They've given us that point. So the slope, all right, that's going to be, all right, here's how it goes. It's always the horizontal change in the bottom, and the top, it's the vertical change. Right now, I always take the horizontal change first because those are the inputs. So I'm going to start here. How do I get from this point to this point? By making horizontal and vertical changes. So if I'm here, I need to come over 2. So I'm going to the right 2. So I'm going to write that the slope is, I'll put a +2 in the bottom. And then if I'm down here, I go over 2, and then what do I need to do to get back to the point? 1, 2, 3, 4. So I need to go up 4. All right, so the slope here is 2. Now, I know that by looking at the graph only because they've given us these points that seem to be right on the graph. But just to be sure, if you want to be absolutely sure, you can use the slope formula, which is this. Second y minus first y over second x minus first x. Now, if I identify points, if that's the first x and that's the first y, now I'm saying this because as I look at these, as I look left to right, which we typically do in graphs, this is the first x I see. This is the first y I see. And then I come up here. This is the second x that I see. That's the second y that I see. All right, so now when I substitute these values in, I'll get m equals, okay, what's the formula say? Second y minus first y. Now look at my picture over here. My second y is hard to see. It's -5. First y is -9. Be careful. It's hard to see on that graph there. So I get -5 minus, careful, -9 over second x, which is -4, minus first x, which is -6. So I'm going to get -4 minus -6. This gives me -5 plus 9 over -4 plus 6. There is our 4 over 2. All right, so now I can absolutely conclude that the slope is 2. This is a better way to do it because if you're looking at a picture, you don't know for sure if that point is right on that coordinate line, that intersection. Let's find the slope of the line containing these 2 points. Now the 2 points are 0, 7. Now that's right on, there's no fractions here, so I know it's right on that intersection, right on that coordinate part there. And this one is 5, 0. So I'm just going to do this by a count. So what do I need to do? I'm going to start at this point here, and I'm going to look left, I'm going to look right to left. I'm sorry, I am going to look left to right. So what do I need to do to get from here to here by making horizontal movements, horizontal and vertical movements? So I'm going to make this thing a little bit bigger so I can actually see it. So if I start here, I'm going to go over 1, 2, 3, 4, 5, and then, okay, so I'm going to the right 5. Let me mark that down here. So I'm going to get that the slope is equal to, all right, remember it's the horizontal change on the bottom, vertical change on the top. So the slope is going to be, I'm going to the right 5, all right, that puts me, right, there I am at that point, 0, 7. I go to the right 5, and then I have to go down 1, 2, 3, 4, 5, 6, 7. I go down 7. So I'm going down, so down 7. And there we have it. There is the slope. And I did that by just looking at the picture and not using the slope formula. And we want to find the slope of the line that passes through these 2 points. Now, we're not given a graph, so let's use the slope formula. If there's a formula, I like to start out by writing it. It is y2 minus y1, or the second y minus the first y, over the second x minus the first x. And as I do this, I'm going to label, as I look left to right, as I look this way to this way, this is the first x I see. That's the second x I see. So I'm going to label like this. This will be the first x I see. That's the first y I see. That's the second x I see. That's the second y I see. So let's substitute in here now. We will get, all right, second y minus first y on the top. So second y is negative 3 minus the first y, negative 6. Just be careful with the negatives. We will get negative 3 minus negative 6. And in the bottom, second x minus first x, well, that's going to be 1 minus negative 5. So I get a 1 minus negative 5. So we will get negative 3 plus 6 over 1 plus 5. So how about 3 over 6? So let's claim that the slope here is 1/2. Now what that means is this. Remember, the bottom is the horizontal change. The top is the vertical change. So what it means is that if we're anywhere on the line, just imagine you're on the line. Now, here's the slope. It says the horizontal change is 2. So if I start at some point on the line and I increase this by 2 units, the corresponding vertical change would be 1 unit. And I'm going to go up because it's positive. All right, so I would go over 2, up 1. And then the line would pass through those points. Well, in 6, we've got a horizontal line. Got to look closely. You can see it down here? Right, it's a horizontal line. So find the slope. Well, here's one thing I know. The slopes of horizontal lines is 0. Now, here's how we can verify that. Here's the slope formula. y2 minus y1 over x2 minus x1. Now, just go left to right. What's the second y minus the first y? Well, as I look left to right, here's the second y. Right, there's the second y. Here's the first y. So I'm going to get negative 4 minus negative 4 over the second x minus the first x. Now the second x is 2. The first x is negative 3. So this is going to be 2 minus negative 3. So now I get that m is equal to negative 4 plus 4 over 2 plus 3. I get 0 over 5. Slope is 0. All right, so from now on, you just know that horizontal lines have slopes of 0. We're supposed to find the slope passing through these 2 points. I'll write them a little bit bigger here. 4, negative 2. So to the right 4, down 2. And then to the right 4, down 5. Okay, I see something suspicious right away. Look at these. If you were to graph these, what would you do? You'd go over 4, to the right 4, and then down 2. And then what about the next one? You'd go to the right 4, down 5. All right, so both cases you're going to move 4 units to the right. This looks to me like a vertical line. Let's use the slope formula and see what happens. So the slope formula says we will get y2 minus y1 over x2 minus x1. This will give us, okay, second y minus first y. Second y is negative 5 minus the first y, which is negative 2. So I'm going to get negative 5 minus negative 2. And the second x minus the first x. Now the second x is a 4 minus the first x, which is also 4. I think you can see it now. So what do you get? You get negative 5 plus 2 over 0. You get negative 3 over 0. And that is undefined. All right, so this slope does not exist. This slope does not exist. Vertical line. Vertical lines, horizontal lines have 0 slope. Vertical lines have undefined slope. So if it exists, find the slope of the line that passes through these points. All right, so I'm going to label here. As I look left to right, that's the first x I see, that's the first y I see, that's the second x I see, that's the second y I see. So the slope formula says to do this. Take the second y, subtract the first y, the difference in the two y's. Take the second x minus the first x, find the difference in the x's. So in our case, we will have, all right, second y minus first y. It looks like negative 16 minus negative 11 over second x minus first x. So negative 14 minus negative 12. So negative 14 minus negative 12. So how about negative 16 plus 11 over negative 14 plus 12. So this is negative 5 over negative 2, and negative over negative is positive. So I'm going to say that this slope is equal to 5/2. So the bottom, just keep in mind what it means. The bottom is the horizontal change, top's the vertical change. Now, I could also say it this way. The horizontal change is always the change in the input. The top, that's the vertical change. That's always the change in the output. So what this says is this. Like I'm thinking I have an applied problem. It would say this. If we increase the input value by 2 units, right, so whatever the input is, increase it by 2 units, the output value will increase because we have positive numbers, will increase by 5 units. Okay, on the graph it would look like this. If you increase this one by 2, the vertical would change by 5. Find the slope of the line containing these 2 points, negative 2, negative 6, and negative 2, positive 6, if it exists. Now I notice this right away. These x values are exactly the same. That means I'm going to be on the graph someplace. Say we're on the graph. I'm going to go to the left 2, down 6. Then I'm going to go to the left 2, up 6. Well, my horizontal change is the same in each case. So I'm going to end up with a vertical line. And vertical lines have undefined slope. And as long as I know it's a vertical line, I could just write, I've got undefined slope. Now, if I have to prove it, I'm going to use the slope formula, y2 minus y1 over x2 minus x1, which is going to be, all right, difference in the y's, 6 minus negative 6, right? Second y minus first y, 6 minus negative 6. And the x's, all right, second x minus first x, so it's going to be negative 2 minus negative 2. This will give us 6 plus 6 over negative 2 plus 2. So I get 12 over 0, and there you have it, undefined. Now I want to find the slope of the line containing these 2 points. Now look how they're writing this. F of 3 is 8. Okay, well this is typically the x value, and this would be the y value. So when you see f of x, that's another way of writing y, right? So what I have is that's the x, here's the first x, that's the second x, this is the first y, this is the second y. So it's really these ordered pairs. So I'm thinking this. Put in a 3, and you can see you're putting in a 3, right? The 3 is going in. You input a 3, and outside you get the 8. So in goes a 3, out comes an 8. So I get 3, 8, put in a 3, get out an 8, and then I input a 7, I get out a negative 7. Now, by the slope formula, the slope is second y minus first y over second x minus first x. So second y, negative 7, minus first y, minus 8. So negative 7 minus 8 over second x, 7, minus first x, 3. So I get 7 minus 3. So we're going to get negative 15 over 4. Now, that doesn't reduce, so there's our slope. And what this would tell me is if I started anywhere on the line, if I increased the inputs by 4, right, it's positive, so I'm going to increase the inputs by 4. Now, that's horizontal on the graph. What about the vertical? Down 15. So if I'm on the graph, if I go to the right 4, I would go down 15, and I'd be back on the graph. Or you can think of it this way. If you increase the number, if you've got an application going on, if you increase the input by 4, right, so whatever you have for your input, increase it by 4, then the output is going to decrease by 15. You put 4 more units in, you get 15 units out.